Hello, everyone. Today we are here for the session Building a Data Engineering Portfolio with Anju Mercian. I would like Anju to share her screen and enlighten us with the talk.
Thank you so much, Mansi. Welcome, everybody. Thank you for joining this session. I will start sharing now. Okay. Can you see my screen?
Yes, we can see your screen.
Okay, so thank you, everybody. I'm Anju Mercian. Welcome to my workshop. I don't know whether called workshop or presentation, but kind of the both, to my Building a Data Engineering Portfolio project. So when I was creating this workshop, what I was thinking was to give everybody an idea or like a template of how to build a project. Like how to build a data engineering project, what will amplify your portfolio, what will help you to get through a portfolio. Because when I was trying to work on a portfolio, it was very difficult to figure out what exactly I need to follow, what exactly I showcase. So from my learnings, and from all the online courses that I also took, I've created this small presentation, and this is what I'm here to share. So let's go over the agenda for the evening. First, I'll just go a little bit about talk about who I am and what I do and everything. Then I'll talk about like introduction to portfolio, introduction to data engineering. If suppose you had joined one of my conference talk, the beginning introduction may be familiar to you, but the project that I showcased there and the project I'm showcasing today is different. I'm also extending it with Spark. So that's why I have like two parts. Today I'm going to speak about Apache Spark, and the next part 2 session I'll be talking about Airflow. And what is Spark, what is Airflow, I'll come to it, but like that's why I'm having like 2 sessions on how to build it. But this is a new project, and but the first introduction slides are all the same if you had attended my conference talks, but I'm just going to repeat for the new audience here today. Then we'll go over the technical skills that are needed for a data engineer, the project steps. Then we'll talk a huge chunk about Apache Spark, what it is and everything, and the code walkthrough. And then I'll open up for Q&A. You can keep all your questions or even keep putting your questions in chat. Stephanie and Mansi will help me moderate, and I'll go through Q&A at the end. Okay, so about me. Hi, I'm Anju Mercian. I graduated from Syracuse University with Master's Computer Engineering, and I've been in the industry for almost 10 plus years. I worked as an infrastructure engineer, project manager, business system analyst, and platform engineer. And then like 2 years back, I kind of got interested in data science, data engineering. I woke up my data passion 2 years back, and then I started getting interested and started studying and looking into it. And currently I work as a data engineer, and that's about me. Okay, so let's go into it. What is a portfolio project? Portfolio project is nothing but a capstone project. That's a well thought out design capstone project. So in this presentation itself, I'm going to go over like a template on how to think through a project. And if you like, when you think through the project, this project will help you like with your skills. If it's something like today hopefully there'll be a new Apache Spark will be a new skill to you. So working on a project will help us with new skills, learning new skills, showcasing skills are the main thing. So you can put it on a website and say, hey, I've done this project, so I'm kind of good at it, like how I show people. So then I also like grow it as a side project. It's this actually going through it right now. Working on side projects like this, working on portfolio projects like this is actually helping me in my day-to-day job, also my 9-to-5 job, because I'm learning something more, a lot new stuff when I go over it again and again, like by doing my projects, while creating presentations like this. And like some of this, and it helps me back in my project, right? I learn here and I go apply there. So it is kind of like a win-win situation. The project helps you get a job, hopefully it helps you get a job, and also helps you kind of keep up your skills and kind of like grow into a side project. Maybe that becomes your passion, like how all the content creators today are. So and then build your personal brand, and then help with data design interviews. Why I say help with data design interviews is because when you're designing the project, you're putting so much thought into how the data modeling happens, how like fact and dimensional tables are created, which schemas to use, star schema or snowflake schema. So that usually helps in data engineering design projects. Because usually in one of towards the end, the final rounds will be like a design interview, and they will like give you raw data and ask you like what kind of table, and give you like the business motivation for it and ask you to build tables for it. So from raw data, you'll have to convert into user data that will answer to a business motivation question. So this project will actually help you through these projects. Like when you build your own portfolio project, will help with that. So that's about portfolio project. Now, who's a data engineer? What is data engineering and who's a data engineer? So data engineering is nothing but somebody or tools and technologies that helps us convert raw data to user accessible data or user-friendly data, because there's a lot of data being collected right now. Every company collects so much data about us. Not PII data specifically, because that has a lot of rules and regulations now, so that's being taken care of differently. But just our usage of stuff, how many times you use, like for example, Apple iPhone, like each time you send like messages and everything, it's being collected somewhere. Some of the metadata is being collected. So we have like petabytes of data is available. So so as data engineers, our job is to actually use that raw data, which comes in raw format, in many different formats, convert that to what a business owner is asking, your manager is asking, your TPM is asking. So convert it for them in such a way that you can put in a dashboard and say, okay, this person, what time usually phones are being used a lot. Those are like the business motivation behind it. And so as a data engineer, your thing will be to build all that, build pipelines and everything. So that is what data engineering is all about. It's like actually is a nutshell, nothing else but convert raw data to user accessible data, user-friendly data. And who's the data engineer? Somebody that knows how to convert that. So knows the systems, knows the tools, comes up with new ideas, technologies to actually make that better. So the technical skills that are needed for a data engineer, the main skills that is needed, at least in the current environment, is SQL and Python. Because everything currently, even though like if I talk about Spark is actually built on like the functional programming language, Scala and Java. But now with the new version, like with Spark and everything, we have upskill kind of, and like everything is in Python now. So these two are, first of all, in interviews, they'll actually question us on SQL and Python, and especially how quick we are in solving problems. So if they give you like 10 problems of SQL, 10 problems of Python, you should be able to like solve quickly. And at time, so in 1 hour, if they give you, you need to solve at least 80 to 90% of it. For FAN companies, you have to like solve 80 to 90% of it. Like many other companies, above 70%. How quickly you solve is like how good you are with the language. So those two are the main skills. Then additional skills that are needed is knowing cloud deployments. I'm just written AWS here, but there's Azure, there's GCP. These are all well known. They're also open source cloud projects and everything. Actually, in the part 2, I will have a little bit of AWS cloud deployment, like how to do infrastructure as code for AWS. So AWS has different technologies, I say, like EMR, Redshift, and S3. So S3 is data storage. If you have used AWS, like you store data there. Redshift for analysis, data warehousing and analyzing, and EMR is also for analysis. So knowing cloud, knowing Apache Airflow. Apache, actually, to tell everybody one thing is knowing Apache Airflow was very helpful in my job, because almost all companies are actually using this, because that's for automated pipelines. It's like you create pipelines. When I say pipelines, it's basically our ETL, which is extract, transform, and load. So all the functions that we use for extract, transform, and load, we write this function and put it into Apache Airflow. So it'll automatically, like you give it when you have to do it, hourly or daily, or depending on the time, it'll automatically run in the background. So it's like a cron job that runs in the background. So that's actually knowing that is actually very helpful. At least knowing how it works. Even if you don't want to get your hands dirty on it, but at least knowing how it works will be very useful in your day-to-day job. They usually don't ask in interviews if you know that, because that's something you can learn on the job. But knowing that will actually give you kind of heads up, not heads up, an up for compliment to everybody else who may not know it. So knowing that is very good. And actually, there are many different tools. This is one of the tools. This is open source also. So Apache Airflow, then we have Spark. There are many tools to handle, or many languages to handle big data. Spark is just one thing, one of the many. And Spark is currently, well used in the industry. So many new companies are coming to handle big data using Spark too. So I put these two on top just to say that these two are the most important, especially to get through a data engineering interview and get into a company. And AWS Airflow and Spark and everything is like additional, which will help a project, or which will even help you as a person to learn. Okay, so now the steps to guide you. There's a GitHub link. I've just uploaded for this week's whatever I have for this week's. I need to clean it up. It's just my raw code that is there. I'll clean it up and upload it after next week's workshop. But this has all what I'm going to go through today. The GitHub link. Maybe I can share the GitHub link. Share the GitHub link, and that has both the code that I have today. So going into the steps of the project that will guide you. So this happens in companies too, right? So anytime, so that's the same template we're going to follow even for this project. What happens in a company? So first and foremost, somebody from the business side, usually somebody from like a TPM, like a technical program manager, will come and say, okay, hey, I want a dashboard, for example, to see, let me take a, for the okay, I don't want to talk about this project, but for example, like you have a song database, and the TPM, the technical project manager, comes and says, hey, I want to know how many users are there, and which are the songs that are famous in our music system, which songs are the most famous. Can you give me a calculation and give me a dashboard build? So what do you have to do as a data engineer? First, you need to go and find out which raw table has this data. So that's where we start gathering data. We gather data, find out which tables have the data. There were many different tables, like because of GDPR and all the privacy laws, usually the user information table will be completely in a different table, which is very protected, legally protected, right? So then you need to go and get that information table that is, ask the required permissions, and gather the data. So you gather the data, then you need to explore and assess the data. So you find out how many nulls are there, what are the actual columns that are needed, what kind of joins we need to use. This part is explore and assessing the data is very important, because this is where you have to design. This is where you have to figure out which is going to be a fact table, which is going to be a dimensional table. What is a fact table? A fact table is nothing but that contains the facts, right? So it's like how many songs, author name can also be in a dimensional table, like, but how many songs, how many users, all this like facts, they can't be changed, right? Those will be in the fact table. And then you build a dimensional table about it. Dimensional table is not it's like kind of like what kind of songs is, like pop or rock, the description of songs, the description of the person, like male or female, which area they're from. That can be a different dimensional table. So that's what a dimensional table is. It's a fact table is. So here we'll decide, we have to decide which is going to be a fact table, which is going to be a dimension table. Then what kind of schema are we going to use? Now the popular schema that is there is star schema and snowflake schema. Star schema is nothing but you have one fact table out of which arises different dimensional tables. So there'll be like, so it's like a star. It's like one fact table and then different dimensional tables. And then snowflake schema is like many star schemas. So many star schemas connected by a fact table. Usually fact table is one that is in the center, and the dimensional tables are the nodes or the outgoing arrows, you can say. So which one? So many companies use snowflake schema, but when deciding that, you need to figure out the scope. Like, is this what kind of scope is it? Is it like daily review, yearly review? What kind of reviews are they going to do with the dashboard? Based on that, you need to create your schemas. So if it's like a very small project and it's going to be like a daily review or something like that, or a weekly review, you can just use a star schema, just pull in everything together, use a star schema, do a join, do a star schema, and put it on the dashboard. If it's going to be like a major thing, then you can use snowflake schema. But snowflake schema, requires more processing in the back end. So you must also think about the performance of all of this, right? The dashboards shouldn't be usually very slow. So you need to figure out how to get the dashboards faster. So your schemas are very important to figure out how fast the dashboard is. So if you're showing the dashboards the executive level, it shouldn't be slow, right? So all that decisions, all those final thought points must come in here in the explore and assessing the data. Then you define the data model based on that. Here you completely do the logical. Here you're doing the digital model. Here you will like the physical the models. Basically draw the design. If you have been a data analyst, you know there's something called a BRD is written, which is business requirements document, or like if you're technical, is like technical requirement document. Like there are different kind of documents, right? What is done here, you are defining it, you're writing it down. Then here is where you're doing the actual coding and work, which is in in ETL, like you're running the transform load, you're actually taking the data, and here you're coding. Here you are sitting and working on your stuff. You have all what you have to show. You have all of your requirements. Everything has been written. Now you're going to do the hard work of writing the extraction, transform load functions. Then you create the pipelines. Then you build it on the dashboard. This is how usually a project happens in the real world, and this is how we are also going to start thinking about this project too. This will hopefully, we get into rut of thinking like that. Okay. So for this, for a long time, I have been only using whatever already there. This time I've kind of gathered data from the public data sets. And I was thinking one day, what exactly should I go? What data should I do? What questions am I asking? What is my motivation? What do you want to see? And I was thinking, and I was actually going to like Target, and there they had written a sign of "Be careful! Don't leave anything in your car. Cars can be broken, and if you leave it, you're gone." So I was like, "Oh my God, there are robberies here. So maybe something with crime. I should do something with crime." I thought of that, and I said, "Okay, maybe I'll take crime data. Okay, so." Then I don't want to live in this place, right? So okay, property data. So I don't live. So let me see how many people are not there. Then I thought about the weather. It was very hot there. So that's how I came actually in front of Target. Is when I came up with this thought of this table. So let me build a table to figure based on the crime rate. This I think everybody would have been everybody buying a house would have thought about this. But this is something I also thought. This is not something new. This is not like an enlightenment I got, but this is something that came to my mind. So I took the crime rate data and the property data and trying to understand. So based on the crime, what's the property? Then I was like, okay, so if there's higher crime rate, property will be lower, right? That is knowable, but I just want to see it in my dash. And then, but based on that, I want to do something else. It's like weather. How does crime, weather, and property align, and how does crime and weather align? So is it like in summer there are more robberies than in winter, or there are more robberies or crimes, violent crimes in winter than in summer? That's just my thought process. You can also you can come up with your own. This is just what I thought, and also if you want to enhance this, you're welcome to enhance this too. This is up to you. So that's what I thought, and that was my business. That was my motivation for this project. So I came up with the motivation. This is what I want. These are the questions that I'm asking my data. To answer my questions, I'm going to have to find the data. So yeah. So I searched the internet. So I have a list of links where you can find the data at the end of this, and also I have a Medium link that has kind of the places where you can go get data. I can share the Medium link too. So I searched, and this data.world and public data sets. This is all public data sets. Somebody told me a long time back is that try not to use Kaggle data sets, because Kaggle data sets has become one of the most used data sets, and it's now very, very clean. There are many people have started using Kaggle data sets, and Mansi, yes, Stephanie, if you can hear me, just let me know, right? If I get cut off, please let me know. Because I'm just talking, I don't hear anybody. Sorry. So yeah, so somebody told me don't use Kaggle data sets. It's like the most clean. It doesn't impress employers. It doesn't even impress anybody. So go out into the world, because many data sets are publicly available. There's like Google data sets, Reddit data sets are publicly available. So if you go search, it's all available. But the problem with using these data sets is that one, there'll be raw data. It's like sometimes the data is like really bad. It's in many different formats, so it's actually very challenging to work on it. And I'll show you why. Because in one of my just completely raw data analysis, you'll see a lot of data which is just all over the place, and then you have to work on the data and get it. So it'll be very challenging, and also you learn a lot. But one thing we have to remember in public data sets is that your privacy data, sometimes privacy in the sense like maybe names, or names are usually not there, but sometimes privacy data may be there. So you should just be aware of it. Most public data sets won't come with that, but sometimes we may get stuck in that. And so you should be aware of that. And sometimes one thing I wanted to mention is that sometimes some data sets are paid, so you don't really have to do paid. Paid is usually for companies. There are even for like housing data set, the Zillow, which I found was actually was free. That's why I have kind of like from 2000 and 2013, the latest actually paid. But I was like, okay, I'm just trying to understand the data for my own thing and to share it with everybody. So I'll just do 2000, 2013. But there was another spot where I could go and actually pay for it. Or sometimes it's something called Bridge API that you can get access to. There is free available, but you can get access to only through like this, what is that? The one realtors. If suppose a realtor can give you access, then you have that Bridge API, which is actually very beautiful. I really liked it, but then I later on learned that you have to go only through a realtor. But Zillow actually closed it, and Zillow data is actually on a Bridge now. But from 2013 was available, and that's what I took. So that's about the data. So I explored the data. I got all the data. It took me some time to get all this data, got data. Now I'm going to do the heavy work, right? So from the data, I have built, this is what I'm building this. So here, when I write fact hyphen is usually the fact table, dim hyphen is usually the dim table. These are not like industry standards, like fact hyphen and dim hyphen for fact tables and dimensional tables is not industry. Like it's not like an enforced standard, but it's kind of understood standard. So for the fact table, you write fact underscore and then write the table name, and dimensional tables, you write dim underscore on the table name. That's kind of like a known industry standard. So here what I'm doing is I'm building the crime table. So the crime table was huge, and there was a lot of data that was there, which I wasn't sure whether very much needed. So what I did, only the actual facts about the crime, like the year it happened, which region it happened. Then there's like kind of what was the kind of violent crime. That's what the strata level name is. What is the kind of violent crime was it? Was it like an assault, or was it manhandling and stuff like that? So there are different types of crime, and all that I put into the fact table because those are facts. And then in the dimensional crime table, I just took out all of the other details like code details, the rate, the population details, the indexes, they had a different type of index. All that I brought it down into a different table here. And here, then the housing table, I put it all together. So now if you see on the housing table, the dim housing table, you'll see this year 2000 average 2000. So this is something I'm building off, because for every month in a year, they have taken the average of the housing prices for that market. And this I've only concentrated on a condo. So I still have work to do on that to merge all that, but this is what my plan is, to use all of this data to try to answer my questions. And I'm using a star schema because my database is very small. and so I'm just using a star schema. I don't want to complicate it. I could have, if you want to, we can, because we can take this dimensional table and make all of these as facts, the average, the rates of the housing as facts, and make that at a housing table and a dimension fact table and dimensional table. But as like, let me keep it as a star schema. Okay, I did that. Then this, I think, this data quality checks and modularizing into data, I'll show more about it in the next session. But today I actually wanted to focus on Spark. So then I run the ETL model, then I'll deploy it on GitHub or dashboard. So deployment is also something you can do. You can use Google Studio, or GitHub deployment itself is good. You can just join the table and answer your questions. That's good. Okay, now coming to Apache Spark. That is what majority of our presentation is going to be today. So before getting into Spark, we have to talk about big data. So what is big data? So you have, like, on a single machine, you have 8 gig. I know you have a lot more now. You have 1 terabyte too. But for example, there are machines. The standard is 8 gigabyte. If there is anything that is more than 8 gigabytes, so if there is data that you need to process which is greater than 8 gigabyte, it's big data. That's common sense, but it's bigger than a system, so it's big data. And anything is smaller, 2 gigabytes, you're trying to process on 8 gigabyte memory, it's a small data. And then if it's 8 gigabyte, it is like medium data. You should be able to process 8 gigabyte. Now, for example, so we've understood that big data is basically a lot of data, and medium data is 8 gigabyte. Now, for example, you have 8 gigabyte of data that you want to process. If you have nothing else to process, nothing else the system is running, and you want to use all your system to process this 8 gigabyte, you're going to be successful. The first run is going to be successful. Now you're like, no, I want to use my 8 gigabyte. You know what I'm going to do? I'm going to like chunk it and do 8 gigabyte, 8 gigabyte, 8 gigabyte, and try to use that to process. But I'm going to use it on a single machine. Can you do that? You may be for the first 8 gigabytes, if you're using only to process that, you will be able to be successful. But what happens to the second 8 gigabytes that comes? When the second 8 gigabytes comes, it's going to be very, very slow, because the 8 gigabytes, the 8 gigabytes. So for example, you're taking a sum or something, sum of numbers. You first take the set, you sum it, you have to store it. So it'll take it into your CPU, it'll sum it up, and it'll go store it in your random access memory, right? Store it, and then the other 8 gigabytes trying to get in. But what's going to happen? There's something called thrashing is going to happen, the in and out of memory. Okay, so that is going to slow down your system. System is going to keep running. It's going to take forever to run. So when that happens, you need like big data tools. Okay, fine. Now you're going to maybe chunk it out smaller, 6 gigabyte. But by the time you process, suppose for example, you have 100 gigabytes of data and you have 8 gigabytes of memory, and you're chunking it to 6 gigabytes, just imagine how long it's going to take, right, for the 100 gigabytes to come. And it's just a waste of time. Then you think, okay, I have this, let me send it to my friends on email and try to get it back. Now, that may be delayed, because not everybody is just going to work for you and give you all the data. So when all of this you combine, we have to use something called big data tools to help us, right? Because you have large data, you kind of want the data faster, you want distributed processing. This is where big data tools come in space. Now, why Spark? Spark is actually, there are many you may know about Hadoop and Hadoop, because that's well known, and Hadoop is like the storage system. So Hadoop was kind of the first one that were built for big data, and that's still news, but it's kind of the the older framework. But with Spark optimizes the memory and minimizes the using network. Okay, that's what Spark was designed. So that's big data. Now, this is numbers that when I was doing my online tutor courses, this is numbers that everybody said that you should know. So your memory takes around 100 nanoseconds to process. Your SSD, which is a long-term storage, uses 16 microseconds. Okay, there itself, you know which one is taking longest. Then network is 150 millisecond. Okay, nanosecond is the smallest. Then it's microsecond, then it's millisecond. And CPU is 0.4 nanoseconds to process. So if you see, CPU is the fastest processing right now. So it's processing faster, it's giving out results, but when you're trying to take it from long-term memory to the short-term memory, that takes time. So that is where the trashing happens, and that's where it's kind of slow down. And now if you include the network too, it's actually going to slow down a lot more. So that's why systems like Spark are trying to reduce that, reduce the time and get faster processing. So kind of equalize to the CPU level of faster processing. So that's why like Spark and all is like well used now. So that is where Spark comes. So Spark is actually a data processing framework that can quickly perform processing tasks on very large data sets. It can also distribute data processing tasks across multiple computers, either on its own or in tandem. So basically it can parallel or do standalone. With other distributed computing tools, these two are the qualities for to the biggest big data and machine learning processes. Okay, so it was founded by Mate Zaharia, and it was started in the AMP lab at UC Berkeley. So before Spark, Hadoop was using something called MapReduce. Right? Some people are still using MapReduce. MapReduce is still there. MapReduce is still efficient. But one thing with MapReduce is not user friendly. Like if everybody, there's a learning curve to MapReduce. So what does MapReduce actually do? Because Spark actually uses the MapReduce logic too, So suppose if you want to take a calculation of the number of songs in a database, so there's like these many songs are available, it first does a mapping. First, it actually, if you're doing it in Hadoop and distributed computing, it'll like break it down and send it to different computers, and then it'll do mapping of which song is there. So there's like 111. Then it does another calculation, maps to another, and then reduces it to this. So that's what map reduces. Maps to a tuple kind of a thing, like or to count, maps to a count, and then reduces that count to the actual count. That's what it does. Hopefully this is good enough to understand. It actually goes by the word map and reduce. And Apache Spark actually uses MapReduce in the backend. Not uses MapReduce the backend, sorry, uses the logic of MapReduce. MapReduce is different from Apache Spark, kind of, but it uses the logic of that. And main thing is it's user friendly. Okay. So I am telling here that Spark is faster than Hadoop. It is faster, but Hadoop can be used as storage. Actually, Spark is also used as storage, but some of the older companies that have big data tools have already started with Hadoop, and they were using MapReduce. They didn't have many developers, and when after Spark came, it became very easy because Spark uses SQL and Python, and it's very easy. Many people know Python and SQL, so it's not much learning curve. So what they started doing is using Hadoop still as their backend as storage, as a big data storage, and using Spark in the front end to like talk to Hadoop. So, but Hadoop is the older technology, and Spark is kind of the newer technology. Okay, so this is the architecture for Apache architecture, Apache Spark architecture. There's something called a driver that actually divides a given program to different tasks, and it sends it to different nodes in the distributed computing. And the different systems do the tasks. So they are the executors. They work on the tasks. And there's a cluster manager. So you may have heard about Jain. Jain is a resource manager. There's Kubernetes and Mesos. They're kind of cluster managers. It manages all these clusters and report back to the driver. But the driver also has access to the executors. But the driver doesn't do management of the clusters. There's something called a cluster manager that does the clusters managing. Now there are two modes to to a Spark architecture, which is local mode and a cluster mode. We are actually only going to work on the local mode, not on the cluster mode. And because I don't have, like, one thing is setting it up, and two is like there's no data for me. My data is almost, it's not much. So it's like 1 million rows and less than 2 million rows I have of data. So, and usually we all use local mode, but the thing is that in companies, when you go and you don't, you will have cluster, it'll be cluster based, but it's easy to learn once you know local mode, how to operate on the local mode. If you're not like actually installing Spark in a computer for a company, I think local mode, knowing local mode is enough. Okay. Okay, so this is I'm also giving a difference between Spark and MapReduce. So as I told, MapReduce actually does the mapping and then reducing. What Spark does is something called a DAG, which is a directed acyclic graph. So if you know graphs from mathematics and computer science data structures, it's exactly that. It's like nodes and edges. So you're processing like ETL, like you're creating tables, right? Creating tables is kind of one task. Then you're inserting and running tables. That's like another task. So all those will be your nodes, and then the edges will be your pipeline running. So after you're creating the tables, then you execute, then you insert data into the table, then execute the table. That is kind of a task. So that's what Spark uses, and that's why Spark has been so successful in doing it, because Spark also has a UI that you can go and check out and say, hey, I have the UI, and you can see which processes are running and everything. So that's why Spark. So Spark is great for so many reasons, but so it is, you know, it is one user developer friendly, because I looked at MapReduce. It was very difficult to understand the logic of what they're trying to do. But Spark, since I already know Python and SQL, it uses Python and SQL. So they have built on top of this Hadoop, this MapReduce code, right? They've used Scala, but you still can use Python. It's like higher level language, so it's very developer friendly. It uses DAG instead of a two-stage execution, that is map and reduce. And yeah. And it's distributed. It has in-memory processing, so it's faster. And it's distributed processing also, it's faster because it has in-memory system. So when we are actually executing Spark code, whether it's in Python or SQL, whenever you're executing, let me go into that lazy processing that I talk about. Okay. So when you are actually processing the Python or SQL. So for example, you are doing some sort of sort using on the data frames, right? You're doing sort, and it will but it'll sort on your local computer. So if you see this is your architecture, right? So when executor 1 does its sorting or drop tables, it'll do it on that system, on the executor system, and only after you do something called a collect or show will it actually merge with the driver, actually merge with the cluster and then driver, or just driver, depending on how your architecture is. But then it'll merge. So it'll just do it'll wait until the last moment when you're actually saying, hey, go get me all the data. That is when it'll collect, or it'll show it to you. Until then, it'll be on local system when you're using clusters, and also local system. Or even after you local also, you have to do collect or show for it to go get all the data. So that's how Spark works, but that's how it helps reduce performance. So it doesn't like each time we do like a drop or something, it doesn't go and tell the master, hey, this table is dropped, hey, this column is dropped, hey, this row is dropped. It doesn't do that. It'll wait until the really end moment when the user says, hey, okay, fine, I want the data. It'll go and tell the master saying that, hey, okay, person wants the data, please do all these operations for me. So which is actually called a lazy evaluation. And that's one of the big success for Spark compared to MapReduce. Now, data wrangling in Spark. Spark is actually built with Scala and Java. Why Scala is because it uses functional programming. Why functional programming? Functional programming is perfect for a distributed system. What is functional programming? Functional programming actually uses functional programming uses pure functions, your algebraic pure functions. When you are it uses pure functions like algebraic functions. Like for example, here we have f of x is equal to x plus 5. So now x is only 3. There's no way that x is changing. That's why it's called pure functions, because your input is not changing. Nobody can change your input. Whereas if you use languages like Python, I'll show you, like for example, the Python over here, you have a w here. W is equal to -1, and your function, their function here, you are adding with this is actually global w, sorry for that, this one, it's a global w, and then you're returning something else which you didn't ask for. You're asking func of x, but you're getting a w, so which we can't have, because if you see computing, you can't be working on on an input data and somebody else is adding something of their own to the input data. It's like you have this game, like you're telling somebody a secret or something, and they keep passing it on, and by the end of it, it's completely disrupted from what the first person started. That is what happens if you allow somebody else to like make their changes. If you bring in their individuality, it completely changes. That's exactly what happens with Python functions. That's why they wanted to use something called a pure function, so that the input is never changed. The analogy I learned is bread making function. So there's one bread ingredient that is actually the best, and you want all the bread to taste the same. Then the input to those to make the bread should be the same. It shouldn't be different. The measurements, the timing, the timing to rice and everything must be the same for all the bread. Then only you get the same bread. If you leave it to every different person, every different chef will make it very differently, right? Or maybe different cook will make it very differently. That's exactly what it is. So that's why I use pure functions, and that's why Spark was built with functional programming in mind. So like I said, what's the difference between functional and procedural? Functional is uniform, no unintended side effects, input data is not altered, all functions are pure. In procedural, that's not the case. It's completely the opposite. You can change it within the function. The input may be uniform, but you'll change it, and it has unintended side effects. And Spark can't have that, especially when you're distributed processing. You really need to have the same thing. So like I said, Spark data processing uses lazy evaluation. So it waits until the very end to get us to actually do something to the final output. Then it uses directed acyclic graph to help processing. So if you see here, there's like run me 0, run me 1, run me 2. So there are different types of tasks. And then after all these tasks, then you run after the loop. Then you can also add one more task over there and then run last. So this is what is, so these run me 0, 1, 2, 3 and after loop, they're all nodes and these are all edges. Okay, so that's what we're talking about here. And this DAG is what you can give it to some thing like an Airflow, Apache Airflow, which will actually automate this. So you don't have to keep worrying about it. Then Spark first copies the data. So how the Spark doesn't change the input is first it makes a copy. So a worker node takes the data, makes a copy of the input data, so the input data is not changed, and then works off the input data to give the result. And then using Spark. So Spark is your, okay, that's a basement to your home. And then there is like complete basement. There are many different homes. There's like Python and SQL that you can use. Python is called like is imperative programming. Your SQL is a declarative programming. So what is imperative? Imperative is like how you do is very important. What's
something I found on the web.
Oh, sorry.
According to bake.com, business partners
Alexa,
and contribute
stop.
to company success. It is important to know and understand our vendors. Also important.
Sorry, my Alexa woke up and started saying about baking. So Python is imperative. So the how is very important. So you're baking a cake, and how are you going to bake a cake? Like, you go to the store, you buy the flour, you buy the sugar. The whole process is important for imperative programming. But for us, a declarative programming is what kind of cake? That's all is important. So it supports both. Spark supports Python and SQL. So that's what it does over here. So you work on Python, you work on Spark. Whatever you do, you does the query optimizer, which is basically what the Spark does it. So whichever language you use, it goes back down to a query optimizer that uses Spark, and it does the execution, creates a plan. Now, Spark uses resilient distributed data sets. That's the basic. So everything started off with RDDs. That is the base data structure for Spark. When you use something called Spark context is when you use the distributed data set. So you have a lot of variance when you use distributed data set, distributed data sets. It's a fundamental data structure for Spark. And that is from Spark context. But what we were using, or what is used by many people in the industry, Spark session, which is actually built on top of this resilient distributed data sets, because Spark session is much more higher level, much more user friendly, much more developer friendly. So it's built on top of this, and most of RDD will be hidden from us. It'll be like kind of like the next bottom level from this Spark session, which we are using. Which you're learning, but I have given links to everything, so you can take a look. It's interesting to understand that, but depending on what you're trying to do, you can learn that. That is Spark. Okay. The commands are all same like what we can use in Pandas Python. You have select, you have fill, where, group by, sort, drop duplicates, with column, adds column, aggregate functions. There are all aggregation functions for Spark SQL, average, min, max, all these functions are available. Then there are user-defined functions. UDF is basically anonymous functions like Lambda. The Lambda functions that is available. The window function, the SQL window functions that are available, that is also there in Spark SQL. All these commands are available. So after looking at these commands, you'll be like, hey, why can't I just use this, right? Why can't I just use Pandas and SQL and get my work done? Yes, it's absolutely possible. You can get it done. Spark comes into place only when you're trying to work on distributed data, faster processing, distributed data, fast processing, and huge data. So petabytes of data. When you're using that much data, Spark usually is very fast. A process is very fast. That's why you use Spark. But all of whatever we can do individually in Python Pandas, it's all available in Spark. And here I have a resource here, which I've shared. Beautiful resource. It's on Spark, sparkbyexamples.com. Wonderful resource. If you're working on Spark, you have any questions, you can just look that up, and all the code and everything is there. You can just try that. If you know Python and SQL, you're working Spark from Python and SQL, it'll be very easy to get it done on Spark. Use cases for Spark is data analytics, it's used in machine learning, it's used in streaming, graph analytics. This one thing I want to note is that Spark is not just a data storage system. There are a number of tools that can actually do data storage, but mostly Spark is used for distributed data processing and for faster data processing, faster availability. So efficient memory usage and distributed map reduced processing. That's where Spark is used. Spark has its limitations. It's not very good for machine learning because deep learning algorithms are currently not available as of today, but maybe they're working on it and they'll come out sometime. And there are latencies with Spark streaming. There are other tools for streaming like Storm and Apex and Flink. But Spark is also useful and is being used. So, okay, now let's do a code walkthrough. So here, what I've done in this, if you see the data analysis.ip1by is where I've done from my raw data. Here, what I did first is I went into my raw data and I did all analysis using Pandas. One, because it is it's easier for me because I know pandas, right? And so to start off, I tried that. But the same thing, I am doing it in Spark 2 in my the data engineering Spark thing. So in this, I'm using only Python. There is also SQL that can be used, PySQL, but it's a different set of functions that you need to take. So PySpark.SQL Spark from Spark Session. This is Spark Session is where you actually get the libraries. And Spark Session is above Spark Context. Spark Context is what uses RDD, and that's completely different. When you're using RDD, they have different formats and different syntaxes and different thing you can. But with Spark Session, you can use Python and SQL. So in this code, let me just, Stephanie, you have this time, right? It's already 1 hour it's showing. Oh boy.
Yeah, you have like 30 more minutes. There's no rush.
Okay. Thank you. Okay, so here what I'm doing with the so I have taken 3 data sets: climate data set, crime data set, and property data set, housing data set. So I'm taking a look at it using all that. I am if you see, if you're going through this data set and wondering what is all this data, I will upload all of the data to the folder, to the GitHub, and make sure the data is available for you if you're trying it. The raw data that I got and the data I'm doing from here, because I am analyzing everything. I'm dropping all the columns and also putting it back into a CSV file for usage for Spark. Okay, so all the stuff that I did with the raw table. See, like I told you like raw table has different stuff. Like there's one column completely just explaining what it does, like number of violent crimes per population, and then there's like the 752 is basically for what type of crime it is, So all that is there. And so all of that data is there. So you can take a look at it. And if you have any questions, just ping me. I'm on Slack, Python, Women Who Code Python. And so I have 2 data sets here, which actually is an interesting data set. I'm going to append this data set after with this. So there's something called California building climate zones. So basing on the climate of the particular area, there is like how big of a home can you build. That is also there. That data set is there, and that uses something called GeoJSON, which I just came across when I came across this. And in order to use GeoJSON for on Colab, you actually need to pip install GeoJSON. It was very interesting to me because it's the first time I saw a different extension called the GeoJSON, which is basically JSON that uses regional or geography. So that you have to import GeoPandas to be able to read it. It has everything. It has I don't think there's no CSV or anything. It says read file from GeoPandas. And okay, so you have all of that. So that is I have climate by country, climate by state, and I'm using climate by state. Okay. So we have that. That is that. Now let's go into Spark. Spark is kind of different to install. You can install Spark on AWS, GCP. If there has Hadoop in a system, you can also install Spark over there. But Spark installing on Google Colab, I have it here in the beginning. So first you connect the drive. Then here I'm seeing what is there. I'm just ls and seeing what is there. Then you do sudo app update to get all of what is there. You do sudo app to install. First you need to install your Java because Spark uses Java. Then you go to the Spark database and get the latest version of Spark. You may have to double check this, the version of Spark, all of this to figure out which is the latest version. Because if this version is dead or is gone, is in archives, you'll get an error. So you need to make sure that this is the latest version, or you can use I think they have 3 versions that will be live. And this, I think currently now is 3.1.3, but I'm using 3 here. And then you unload it, and then you have to give you an environment variables of where it is located. is located. Then you install something called a find Spark. So it goes and helps you find Spark so that you will initialize using find Spark. You'll initialize your Spark. That's where you're going to do here. These steps has to be followed. If you're using Spark on Collab, you need to follow these steps. And then you find double checking by finding out. So on your content, it's there. Okay, and you lose it as like it is not permanently placed. So once your connection is gone, it clears GCP, Google Cloud clears your system. So you have to run all this every time you lose connection, everything is shut down from working on it. Okay, so this is where we are talking about your Spark session. Okay, so you're going to use the two Spark context and Spark session. Using Spark context, you can't use any of these syntax that's shown here, because that's all those syntax is for Spark session, which is actually kind of built on top of Spark context. Spark context uses RDD, which is resilient distributed data sets. And then this is how you initialize your Spark instance. Okay, you give in your master, which is low because it's in local mode. I'm going to say local mode, and here I'm going to give an app name, which is data analytics table. Then I'm telling them which port. This port will be, if you're using Google Colab, this port is what you're going to use, because I think I already said that is the port that I'm going to use. Okay, I'm going to use this port here, spark.ui port 450. That's what I'm going to use. Then get or create. So basically, if the app name is already there, it'll get, otherwise it'll create a new one. Yeah. Okay. Now this part, that's actually giving me all what is there, all what the libraries are there, the functions are there, all that, all the details of my Spark session. That's here. Okay. Now here I'm like, like in Pandas, I'm going to read the format, and this is how you read. Like in Pandas, you have pd.read CSV. Here you have spark.read.format. There are many different options for this. This is one option. There's another one also that I've written. I'll come to that. The Spark here. This is where I'm loading the housing data. So this housing data is something I deleted and created from the raw data, kind of like mid-raw data. This is not completely user available data, but kind of mid-raw data over here. And I'm reading it. And if it is a JSON, you can do .json. Oh yeah, so this is the different format. So here you have .read.format, you're giving in input as CSV. You can also do another thing like this, is like you can do read.csv housing path. So depending on what format, so my format for housing data is CSV. You can also have JSON, and when it's JSON here, you put JSON. Excel has been difficult for me. I've not been able to import an Excel file. I have to still find the right format to import the Excel file, but CSV and JSON I have been able to do. And also, like when you're doing a project, one thing I remember tell you is that always make sure that you have different formats. Like a CSV, JSON, Excel, different formats you have, that shows your capability of working with different data formats. There are many different formats like CSV, which is comma separated values, Excel, XLSX, that's a different way of formatting, because and then there is JSON, which is a key value pair. If you have any, then there is Parquet, you can read Parquet. Then how to read your pickle files, pickle file that they're going to storage and you're trying to repeat it back. Knowing all this and also trying to showcase most of this also be helpful. Okay, here. So there is something called .take instead of head, which will come by, but this helps print schema, helps in printing what all is available, all your columns, your data types, everything here, whether it's nullable or non-nullable. All that is it'll showcase in a clear print friendly format, in a neat format. Yes, one of my files is very long. There are lots of columns. There are like 188 columns for my housing data. Or you can describe it. You see, it's not very pretty. It's kind of has a pattern, but it's not very pretty. So this, when you use print schema, it kind of comes out very pretty. So there's something called .describe. then then you have dot show. This dot show is equivalent to like pandas head. And then you can specify how many you want. I think maximum it automatically gives us 20. And so if you do n is equal to 1 or n is equal to 2, it gives that many, right? So it gives me that. The spaces and all is the data, how it is, that's bad data. That it's still to be, as I said, mid raw format, it's like that. And there's also take. Okay, so these functions, the functions that are there, it's just a different way of taking it. So just showing you how it is. Then you can also have, come on, yeah. And that's I'm showing you the fun. Then I'm taking the crime data. I'm doing the same with the crime data. In this crime data, see the way I've taken this CSV is different from how it was there. Here, this is how I read here. And CSV, you need to make sure that you have header is equal to true. Otherwise, it'll just take some header and give C0, C1. It puts its own header. So it'll just give in its own number. So we need to make sure header is equal to true is there for CSV. Then I'm taking it and I'm doing more than that. So I'm selecting a particular column. So you can use select and use it. And using show. So if you just take this, right, dot select, it's just going to give you like kind of a metadata. And then when you do dot show is when you see the data. Okay. So see by default, it'll show top 20 rows. So it'll show the data only when you do dot show. Now but suppose, for example, you are doing like a max or a min or like some sort of aggregate function or some functions, then you need to do dot collect. So that it goes and informs the master that, hey, there's a change, right? Or if you add a new column, then you need to do dot collect. So here I'm actually trying to change this report here is actually is in a float format. When I bring it from the CS, I'm changing it to integer type format here. And that's what I'm doing here. I'm changing it to integer. Then I'm checking the data. I'm doing that. Then I'm doing, selecting columns where the crime unique key is 5, and then I'm doing collect. So, to take the data from, so collect and show is all the same, but show you use only when you want to like show a select value or something. But collect you have to use when you want when you're doing like sum and aggregate functions. Okay, so we're doing that. Then we're doing a count, which gives a count, but it doesn't do dot shape. Just gives you the count of the rows. Like how in pandas you have dot shape, you don't have that. Then you're dropping a column. So call has to be, referenced separately, and your header. And you're getting that. Then I'm analyzing the crime data, kind of doing a group by and count. So doing a group by of the year and counting how many different rows are there. So this only gives me top 20, but I can actually save this into a file and put this out file. And kind of do that here. I'm doing a sorting per year for the climate data, because I have data, if you see over here, I have data from 1746, so I'm going to try to sort it and kind of delete the data since I don't need it. Or maybe I'll just need it, keep it there, So that's done. So if you see, it's kind of the same, just you're referencing Spark instead of like a PD, pandas. Otherwise, it's the same. It's very easy. And then there's also, you can also use SQL functions. I didn't try that there. I will try it there. But you can use select star from, or select all of the select functions also. SQL also you can use. So depending on which language you like to use Python based, you can have Python based. If you want SQL based, you can use SQL based. But everything will translate into your Scala language under this one using the query optimizer, and it showcases that. Okay, that is it. I think I took a little bit. Now we'll go into question and answers. So that is Spark, and for next week, I'm planning to put this all into like an Apache Airflow. Apache Airflow is difficult to install it on our system, so I need to figure out a way to install it somewhere, and then that is something that's for next week. I'm trying. But I also have over here some references for more details and what all. Apache Kafka is also very important, knowing Apache Kafka. So yeah, that is all I have. Now we can move to Q&A. Hi, Stephanie. Stephanie.
Yeah, so we do have some questions in the Q&A. First question, when we gather the data, is it already in internal databases?
When you yeah, it'll be already in the internal database. If you mean the company's database, yes, it'll be in the company's database. Usually if this is a question for a company base, usually companies will not allow you to go for public data sets. Sometimes they may, but most of the companies now are they're coming down the company, so they're very careful about it. So they will always have it in the internal database. But when you're doing for our project, it's public database. But yes, it'll be in internal database for companies.
Next question, what's the difference between dimension and facts?
So facts is basically fact table. That's something that is not describable. It's kind of like it's not it's like facts and like number of crimes, for our database, number of crimes, it's for that year. That's a fact, right? That happened, that many crimes happen, that many crimes are documented. So like if it's a fact, then it's a fact table. Your birth date, that's a fact, you can't change it. Your birth rate, age, all that, those facts will be in the fact table. Usually the fact table is kind of the analytical table. So all your analysis, your sums and averages and all will be there. It's usually numbers. So fact table usually contains numbers. Dimension table is a description. So a person who has curly hair or is female or male or like brown eyes, blue eyes, the description, if you take a description of a person and you're describing the person, all of the description will be in a dimensional table. So anything describing is in a dimension table. That's the difference between facts and dimension table. Yeah.
Awesome. Do you have additional documentation we could read through to understand the differences between star and snowflake schemas?
Yes, I think it's there in one of the things, but if it's not there, I'll make sure to attach it. It's definitely there, and I'll double check it and I'll share it. If you're in the Python, if in the Python Slack, I'll make sure to share it there.
Fantastic. Are there different virtual environment requirements for running in local versus cluster mode?
Virtual, yes, definitely, yes. When usually cluster modes are run in companies, or when you're running in clusters, they're completely different sets of virtual memories that you can use. But when you're running cluster, usually you'll run it on you run it on a bigger data set like AWS S3 or GCP or using Microsoft Cloud, and they'll have their own way of executing that. For your system, definitely always you should use a virtual environment to work on. So you're not, especially when you're using Spark. Spark is like if you're ever downloading Spark and using it in a system, make sure you to always use on a virtual environment. And if you are using Python itself has this V environment. So create your Python virtual environment and use your download story Spark there and use it there. Wonderful. But if you say different from what you're currently using, no. It's you use your Python regular virtual environment, or if you're using a virtual box or a VM machine, you can use that. But if you're using for cluster, if you're using your big databases, they have their own. Yeah.
Thank you. Is there a difference between Spark and PySpark?
Okay, when you say Spark, it includes both Python and SQL. When you say PySpark, is only Python-based Spark, like that. But it's actually both are kind of the same, but it depends who you talk to. Or if you're talking to somebody that's very fond of Apache, they'll just say Spark. But somebody you're talking to Python, but there's no difference in coding or your logic or anything of that. It's just how you represent it. as that's different. All your libraries and all, if you're using Python based, it'll be PySpark. So it'll come from there. If you're using directly Java or directly working on their the Spark code base, then you use Spark but if you're using the higher level of Python and SQL, then you use PySpark. That's the difference.
Awesome.
Where are you working? Yeah.
Awesome.
Which? Yeah.
So this person has a question. When I used PySpark last time and tried to make a bar chart, it smushed everything together. Is there a way to control the window sizes for data visualizations in PySpark?
Okay, actually slicing is kind of difficult in PySpark. Slicing is difficult in PySpark. So to do windows, so what I usually do when doing that, I will convert it into pandas data frame and use that pandas data frame to get my charts. Because slicing in PySpark is difficult for visualization, but if you're trying to do slicing like using a table, creating tables, then we can do SQL select. But if you're using for the box charts or charts, usually what I do is convert to data frame. You have a way to convert like dot to pandas, and then I convert that the SQL Spark data frame to pandas and then get my charts. There are some drawbacks with Spark Python. You don't have that luxury of pandas. It's not as evolved as pandas.
When working on a data science portfolio, what should beginners focus on?
Beginners should focus on getting your ideas right, like templates right, like building your data models. You don't have to worry about Spark and if Apache Airflow and everything. That's kind of advanced. You just have to focus on the basic of taking data, kind of breaking it down into fact and dimensional tables, cleaning the data, basically cleaning the data, making sure nulls, if you have nulls, and you explain why you have nulls, but your primary key shouldn't have nulls, you should have distinct data. All those are what is important. How you are dealing with the database, how you're creating the table, how you're taking care of the table is what's very important for a beginner. So all of these attachments that come on top of it is only after you're done your beginner project. You work on top of your beginner project to get that. So you focus on basics. Like if you have the link to my Medium thing, I'm not trying to force everybody there. I'm just saying that is because here I have spoken about what a beginner should do, like because I was once a beginner too, so I just did that basic project understanding. I can share that. I'll share that in the chat. So you just focus on your tables. Focus on your tables, how to build your tables, your star schema, schema, fact and dimension. These are all very important concepts as a data engineer you should know. Fact and dimensional tables, star schemas, snowflake. Why are you doing that? Like the integrity of your primary keys, your integrity of the foreign keys. What are how are you handling the atom is there, right? In that atomicity, your first normal form, second normal form, all of that is actually understand that is important. So to kind of showcase that. I hope I answered your question.
Okay, next question. I believe data engineering is moving towards file formats like Parquet org. How can we incorporate those into personal projects?
I've never seen Parquet format public data, but you can kind of load your data into like Amazon or GCP into Parquet format. There's a way to actually do that. But it's not like everybody are moving towards Parquet. It's still CSV and JSON and Excel. Even now in my company also we use Excel. So it's there. Parquet and SAS and everything is newer formats. It's good to know, but it's not like the whole industry has moved towards it. I think newer startups are using a lot more Parquet and SAS. But there is a way to, you can actually, on your Google datasets, you can search for SAS format datasets or Parquet format datasets. and you can use that. And here, actually, on my current screen, if you see, there's a way to read that, your Spark and your Parquet. Or you can even take these data sets itself, like or CSV-based format data sets, and you can just store it as a Parquet. You can write it to like a Parquet format, and then you can read from Parquet. That also you can do. Read it for CSV, store it as a Parquet into your, like if you're using Google Colab, your Google Drive, read your CSV format, store it as work on it or something, or otherwise just store it as a Parquet format or a SAS format, send it back to your Google Drive and read as Parquet, and that'll be also interesting to do it. I have not tried it, but that's something you can do to kind of understand the formats.
Okay, next question. How are fact tables and dimension tables different from entity relationship diagrams?
Relationship diagrams are how databases have to be structured. They are the basics for data architecture, database architecture. So you should know that when you're a data architect, or even when you're data science, you need to know how to create entity relationship diagrams, like one-on-one relationship, how are tables connected. The ER diagram and the fact and dimensional tables basically don't have, it's not like ER diagrams, fact and dimensional, you don't have to know, or if you know fact and dimensional tables, you don't have to know ER diagrams. It's not like that. Fact and dimensional table is kind of different. It's just like, it's a kind of ER diagram you use to like architecture your database. Fact and dimensional, you're just splitting it up in such a way that you're trying to take the analysis out description. So if you have the numbers, the analytical numbers in a table, and you're like, what, I don't want the analytical numbers, you take that and put it to a fact table. And then you take a description into a different table. You're just kind of describing the table differently, or kind of like splitting the table in a different way, so that sometimes fact tables will be used more, like if it's numbers, the budget numbers, and usage numbers and all that, fact tables are used. Sometimes only those tables can be used, and they can be used with many different tables, and kind of information. Whereas for dimensional tables, it doesn't have to be always used. So they're kind of different, fact and dimensional, but fact and dimensional, how you do the database, like how you take you raw data and create your own user tables. Sometimes you have this raw data database, and from the database, you're trying to like do another extraction, and you're doing it as fact and dimensional tables. So that's a different level. That's what it is. Yeah. But you need to know entity relationship diagram if you have a data. If you want to be into data, you need to know how to build entity relation tables. And using entity relation diagrams, knowledge of it, you build your fact and dimensional tables. That's what.
All right, next question. This person has 3 years of experience as a QA engineer, and they want to switch careers to data engineering, but they have no experience as a data engineer, and they feel that many companies are requiring 1 year of experience. How should this person tackle this problem?
That's difficult. One thing is, you can work on like volunteer-based projects. Even I used to do that, because I was like a platform engineer, like a different type of engineer, infrastructure engineer. I had not worked on data engineering, but I actually did a lot of volunteer projects, and I used that experience to build my data engineering experience. And I built a lot of projects on the side. I worked for City of San Jose as a volunteer and built databases for them, or data architectures for them. I worked for a volunteer organization called OMDINA, which is a social enterprise organization called OMDINA. I worked as a data engineer for them. I also worked full-time for them before I joined my current company. So I worked also for them. So basically try to study, up your skills, build portfolio projects, build projects, and showcase your projects, and kind of try to see if you can get volunteer work somewhere. And there are many places that want data engineers or data help as volunteers. Now check out omdina.com. and see if they have any projects that you like and try to work for them, because they'll also give you a recommendation. If you worked well for them, if you've done a good job in your project, they'll give you a recommendation too. And it's volunteer. They don't pay you, you don't pay them, it's completely volunteer based. That's how we can gain experience. Yeah.
Thank you. So do you use Docker often for your work projects?
No, I haven't used Docker for work projects for data engineering. No. Docker, I have experience in Docker, but no, for my day-to-day use, I don't use Docker or Kubernetes. Everything is used, like I said, Airflow, right? That's what we use. Everything that's already kind of containerized. So.
Awesome. Do you have any recommendations for resources that introduce learning relational databases? This person heard that Kimball's text, the data warehouse toolkit, is often recommended. This person's been looking at a SQL and database design course in Udemy.
Actually, if you can afford it, Udacity has wonderful courses. Data analytics Vidya, they have wonderful courses for data engineering, for SQL. They also have free SQL courses, I think. Yeah, they have free SQL courses. Udacity has free SQL course. I know that for sure because I take that. The Kimball's, that's also, I have not taken it, but even I was recommended that. So that seems to be a good place to start with SQL too. But other than that, Udacity has free courses. Analytics Vidya, they have free courses. Then Danima's website, you can go and do the 8-week challenge. He has good courses. These are what I do. Yeah. These courses are good. But try out Udacity's free SQL course. That's a good one to start. If you're starting with SQL, they have good introduction in it. Okay. Oh yeah, somebody has mentioned in chat data camp. I forgot that data camp is also good. On chat, somebody has asked, can she make a list of the things she listed? Like, you mean the courses, Larry? You're saying the courses that I said? Yeah, I can make a list. If you're part of the Slack, I can make sure that to share that. The courses, yeah, I can. Oh, sorry, I said those real parts. Okay, let me make a list. One. Then what was it? Maybe is also, yeah. Okay, I don't have to do it right now. Okay, yeah, I'll make sure to share that list like that from whatever I find on Women Who Code Python Slack channel, the resources section, right, Stephanie?
Anju, was there anything else you wanted to cover before we close out?
No, I think I'm good. Yeah, it's all, yeah. Yeah, okay, I think I'm good. If they
fantastic.
have any questions, I'll be available on Women Who Code Python Slack. So you can tag me and I'll help respond to that.
So I just want to give a very big thank you to Anju today for a really amazing session about data engineering. I hope everyone enjoyed it. Yeah, everyone has been really spectacular today. Thank you so much for sharing all of those amazing questions. And so Anju will be back next week, same day, same time for part 2. So very much looking forward to that. If you've registered for this one, you don't need to register for this part 2. You're already registered. So we look forward to seeing you all then. And we also look forward to seeing you at future events as well. So thanks everyone so much for your time. And I hope you all have a wonderful morning, afternoon, or evening, depending on where you're located in the world. Thank you.
Thank you so much. Thank you all for joining. Thank you, Stephanie. Thank you for hosting me, and Mansi also. I think she had a drop off, but thank you. Thank you for hosting me, and see you all next week.
Thanks
I
everyone.
should be.
Bye.